How are you doing? Thank you so much for joining me with another math lesson with Mr. Woodford. Today we're going to dive into our brand new unit, Unit 4. We're going to be talking about geometry, right? This is the unit where we talk about modeling geometric shapes and figures. And most Math 7 classes go straight into proportional relationships, and then they eventually come back to modeling geometric figures. But I believe there is proportionality in geometric figures. Before I teach you how to solve proportional relationships, I want to show you what they look like. So let's look at Unit 4, modeling geometric figures, looking at lesson 4.1. If you have your packet, please open it up to the very first lesson, which will be talking about perimeter, area of triangles. Now, so far in your math understanding, you may have learned a little bit about perimeter, a little bit about area. Today, we're going to reinforce it, if anything, so you have a stronger foundation as to how to calculate it. First and foremost, as usual in every video, take a second to pause the video and complete the bell work, okay? All right, awesome. Hopefully you had enough time to be able to figure that out. You can always still pause it now if you need to, but let's look at it together and then let's eventually dive into what I want us to get through today. We have to read this word problem below and go and solve it to the best of our ability. If you notice in parentheses, I put draw a picture if needed. A lot of times when it comes to word problems, a lot of times when it comes to geometry, I feel it's a lot easier if you draw a picture. If you remember this, when you get into 10th grade and you have to actually do the geometry course, it will help you. If you need to draw a picture, draw a picture. This says two 2-inch plastic strips and two 5-inch plastic strips are used to form a rectangle. What is the perimeter of the rectangle? So when I look at this, I'm noticing that there are 4 pieces of length that I'm looking at, right? It says I have two 2-inch plastic strips. Let's say that those look like this, okay? And then I have two 5-inch ones. Let's say they look about like this, okay? There are 4 pieces here that they want you to put together to form a rectangle. So it looks something like this. Maybe the long ones are right here and the smaller ones are this way. Or you can rotate that and make it where it's vertical, right? But nonetheless, this is your rectangle. And I apologize, my rectangle obviously is not perfect. I'm sketching it, right? But they want to figure out the perimeter. I know that this side is 2 inches. I know this side is 2 inches. I know this side is 5, and I know down here is 5, right? How do I calculate perimeter? And obviously this particular bell work question is to see what you remember about perimeter. For those who are thinking about perimeter, the simplest way to understand perimeter is simply to add up all the sides. So I would do 2 plus 2 plus 5 plus 5, okay? Another way to remember this, and that's length plus width plus width. Another way, which is the more popular, I guess, formula, is 2 times length plus 2 times width. And that would look something like this: 2 times 2 plus 2 times 5. Both of these, no matter how you solve them, is going to give you the same exact answer, which is 14, okay? Now, because it's a word problem and you're used to being in Mr. Woodford class, of course, we need to say that the perimeter of this rectangle is 14 inches square, 14 inches, okay? So the perimeter is 14 inches, okay? All right, let's dive in. There are little things that I want to point out. And the first is just looking at the vocabulary with you. The perimeter is the total length of the sides of the shape. As usual, you will see the vocabulary, one word after another. I'm not trying to trick you. How the words show up at the top is exactly where they fit in their sentences. The perimeter is the total length of the sides of the shape. That's what the perimeter is. The area measures the surface of the shape, right, which is the inside. So the way I want you to think about it is perimeter is outside, area is on the inside, okay? Perimeter outside, area on the inside. There are formulas. I'm going to show you them. We talked about the perimeter formula a while ago. I'm going to show you the area formula as well in a second. First of all, let's look at the discovery. And once again, you can pause the video if you like. I'm not going to. I'm going to go straight through it. I want you to circle all the images that you know to be rectangles. Now, most students may very well circle this first one, and that's it. They will say, okay, well, that's not a rectangle. I'm not talking about the white area on the outside. I'm talking about the actual green shape here, right? They'll say that's a square. They'll say this is a trapezoid. but I want you to also know that the square is also a rectangle. Now, why do I circle it and why do I say it's a rectangle? Because in order to be classified as a rectangle, it needs to have all the properties of a rectangle. So a rectangle, we know opposite sides are the same. That word is called congruent, right? In math, that word is called congruent, which just means the same. Okay, you'll learn this more when you get to 10th grade math. A square has opposite sides that are congruent too. A rectangle has 4 right angles, right? A square has 4 right angles. The diagonals of a rectangle are congruent. The diagonals of a square are congruent. So we see that the square has all the properties of rectangle. So in truth, it can also be classified as a rectangle. Okay, so I just want you to see that, and I just love taking a second to poke people's understanding of what a square is. It's just a rectangle. However, know this, a rectangle is not a square because a square has properties that a rectangle does not. For example, a square, we know all 4 sides are the same. A rectangle, that does not have to be true, okay? But let's keep going. Let's dive into the modeling where we're going to talk about perimeter and area. Our focus today is on rectangles. So if you want, as I mentioned in the bell work, feel free to draw yourself an image. You can see A does not have an image drawn for you, whereas B in the modeling does. And that's okay, because there's going to be problems that I'm going to give you that have a shape. There's going to be problems that does not have a shape. All right. The first one says a rectangle has a length of 8 and a width of 3. Okay. So if you want, you could draw yourself a nice looking rectangle. Don't judge me if mine is messed up. Okay. I'm going to draw the length and write it as 8. The width, I'm going to draw it as 3. If you want to write these numbers on the other sides as well, feel free, right? Because you need to know that opposite sides are the same, right? That's a property in a rectangle. They want me to calculate the perimeter and they want me to calculate the area. Now, what I want you to do is this. Above where it says perimeter, I want you to write the formula for perimeter, which is 2 times length, and that's an L, plus 2 times width. We mentioned above, if you don't want to use this formula, you can just add up all the sides. Let me say that again. You can just add up all the sides. I believe adding up all the sides, if you feel you're a little more weaker in math, adding up all the sides for perimeter is the way to go, okay? Area, there is a formula for area, and the area of a rectangle is just length times width. As you know, that dot in the middle means multiplication. So when I go to calculate perimeter, I could do this. I could say, okay, well, perimeter, and let me just use red for perimeter. It'll be 2 times 8 plus 2 times 3. Or if you did 3 plus 3 plus 8 plus 8, you would still get 22. So here I'm going to say it is 22. Now notice here there is no units in above, so I don't have to put inches or feet. There are no units, so just put 22 there. The area, however, and I'm going to use blue to represent area here, is going to be 8 multiplied by 3 because we know that's length times width. And 8 times 3 is going to give us 24. Okay. Notice that perimeter and area are very similar. They're very close on this particular rectangle, but that doesn't have to be true with every rectangle. Okay. So your goal is to calculate length. Your goal is to calculate perimeter and area. Let me do one more with you before I let you work on the infinite practice. And if you have any questions, as usual, you can put them in Google Classroom. Find the perimeter and area of the rectangle below. Okay, they tell me that this is a rectangle. Tell me the properties are true. That means down here is 5. That means over here is 3. Now, notice that they have the letter M next to it. This letter M stands for meters. Okay, that means meters. Okay, when I go to calculate the perimeter, right? I'm gonna do it the other way this time. I'm gonna do 5 plus 5 plus 3 plus 3. Okay, this is gonna be 10 plus 6 equals 16. 16 M. Okay. Now to find the area, and this is important for the rest of the worksheet, I need you to know this. We know area is length times width. Okay. If I were to do length, which is 5M, notice I put M there, multiplied by 3M. You and I both know 5 times 3 is 15. That's great. But M times M is M squared. Whenever you calculate the area of a rectangle and it has units, the units are going to be squared. So it's going to be a squared meters in this case, meters squared. It could be inches squared. It could be feet squared. But that's only when you're calculating the area. The perimeter is only because you're adding them up. It stays whatever the unit is, which is meters. It's not meters squared. Okay. As you guys know, this just means m times m, which is m to the second power. Just like when we talked about in unit 3, we talked about squares and square roots, right? We talked about 4 is really 2 times 2, right? Which is another way of saying 2 squared, okay? That's the same thing here, all right? Okay, so feel free to pause the video, rewind it if you need to. That is it for today. Please make sure you practice perimeter and area work and infant practice work on the homework. If you have any questions, as usual, feel free to put them in Google Classroom. Thank you so much for joining with another math lesson with Mr. Rifford. Have a great day.